generalist characteristics. All right, so
I hope I don't want to drink that.
it's just what they do, right? If you're a generalist, can you live most places?
Yes.
Can you eat most things? That's what that's getting at, right? It's broad, just like the range of tolerance. If you're a specialist, you know, a koala, what do they eat? Eucalyptus, and that's about it, right? If you're a panda, they eat bamboo, right? They do eat some other things, but pretty much they're very specific. So, you know, specialists, if the environment changes, what's going to happen? Yeah, they're going to be in trouble.
Will we need like an example?
I don't remember, but let's throw a feed out there. Give me a generalist. Raccoon's the go-to. Rats. If you're a specialist, you're a koala bear. You're a panda.
Wait, elephants will they use for the giraffe?
We need something that's very unique to its location.
We can do tomorrow.
So,
The birds in Hawaii.
We still have all day.
birds in Hawaii. That word, the eewee
We
bird.
still have all day tomorrow.
Not that you have to know the eewee bird. But. Okay, let's move on. K and R species. All right. So I got to be careful not to get too much into this, because these two, well, I lump them together, so we can just. All right. So let's do these two. Okay. So biotic potential is what they're capable of living, where they're capable of living in like the entire area, and what they're going to population size. So intrinsic growth is like biotic potential. It's just we're assigning value to it. Okay, it's like numbers. Intrinsic growth. Okay, so
remember on the quiz it was like, what's the value of it?
yeah, so this is more of intrinsic growth.
value.
Yeah, how much, like how many it could hold, right? Biotic potential is just saying this is what they're capable of doing. One of them uses numbers, the other one's just a non-number value, but it's the same thing. Okay? Got that? And I got some notes, so I want to make sure I remember to tell you a few things. Here's another way to think of it. This would be like the maximum growth, right? That's biotic potential. And intrinsic growth would be the numerical limit. Get it? Maximum. So this is max growth. And this is the numerical limit. See how they're the same thing? But one of them is an actual number. One is just saying this is the maximum growth. Okay. K selected, R selected. All right, so K selected, lots of parental, yeah, I did that intentionally, cool, right? Lots of parental care. Offspring, many or few?
Few.
Okay, few offspring.
Longer lifespan.
Yeah, they live longer,
Low death rate.
longer life, low ER. Okay, so those all kind of go together. And then if we do R means reproduce. All right, so when it comes to care, there's none. When it comes to offspring,
There's a ton.
many.
That rhymes when it comes to. Rhymes okay. There's
Okay,
one like that.
lifespan shorter. They don't live as long. What? They can be invasive. Your invasive creatures are usually your R's. What did I mean by life? What were we talking about?
By what?
What was life?
Lifespan. Long lifespan.
Yeah, lifespan. So shorter lifespan, invasive, and high death rates. That's why they have so many offspring, because most of them die. Okay? So, classic example of a K.
Elephant.
Elephant.
A bear.
Yeah, mammals, right? For the most part. Bears.
Humans.
Humans. These things. What would be an R?
Fish.
Insect.
Frog.
Insect.
Turtle. A sea turtle.
Frogs. Sea turtles. Okay, stuff like that. So if they lay a ton of eggs, there has to be a reason for that, right? Insects do, frogs do, sea turtles do. Because do all the baby frogs? They have to run the gauntlet. Do they survive? You know, most of them die when they have to run the gauntlet to the ocean. So there's a really good Key and Peele YouTube video of sea turtles getting snatched up by different animals.
Why would
should
you
watch
say
it.
that?
What? I just remembered that. I don't know why. So, okay, so tying into this, we have survivorship curves. So what does a survivorship curve look like?
Isn't that?
Yeah?
And then a line in the middle.
Yep. Okay, so what is the top one?
One. Type 1.
And 2, and 3. Okay, so let's tie this into up above. Which of these two up above is a type 1?
Okay.
That's K. What's a type 3?
R.
Squirrel. Oh, wait, sorry.
Yeah. So that's how we kind of break that down. So how would you describe the survivorship of a type 1 organism?
Live long.
Yeah, and so here it is.
Species spread.
Parental care, few offspring, they live longer, they have low death rates. You see what I mean? They all kind of tie, that all ties into a type 1. A type 3, no parental care, many offspring, shorter lifespan, they can be invasive, they have a very high death rate. So early on, you have tons of deaths, and some of them are going to live, and that's about it. Okay, and that's your R. Type 2 means
Die anytime.
any day. Yeah, and the classic example are squirrels. Although I put chipmunks in that same category.
Oh, 'cause you killed one.
Okay, yeah, because I did squish one. So there's squirrels, right? Any day could be their day, doesn't really matter. So, if you live in East Chicago, could you be a type 2?
Yeah.
Yeah,
But he's.
it's just a really bad area of Chicago. Yep.
I've been to Oakland.
Michelle Obama was born and raised.
Really?
Yeah.
Okay, so we have survivorship curve, 1, 2, 3.
Take a vacation.
Here we go, type 3 moving to type 1. So, if you're an alligator, right? Alligators lay lots of eggs. Early on, they're really small, so there's a high chance of them getting eaten by birds and fish. But once they get to be so big, they move from being a type 1 to nobody's going to mess with you, you're a type 3. Or type 3 moving to a type 1. So you could be start out as a type 3, but as your body physically gets bigger,
Like baby crocodiles are type 3.
you'll move to being a type 1. Because now you're the king of your area. No one's going to mess with you. All right. Okay. Here we go. All right, exponential growth. So exponential growth, how do things grow?
Rapidly.
Rapid growth because,
Exponential resources.
yes, unlimited everything, so you're going to grow exponentially, right? What's the shape? J-shaped curve, right? All populations grow exponentially, but eventually they do that, which is called a what curve? Logistic, because you have reached your carrying capacity. Okay, So carrying capacity, the maximum number of organisms that area can hold. Okay. If you are growing exponentially, and then you exceed your carrying capacity, what's that called? Overshoot. Or let me do a better job on this. So you go this and then this, right? So this is the overshoot, and then because there's so many of you way above the carrying capacity, there's a die-off. So let's say it's a really good summer, lots of food, the animals are reproducing like mad. Now there's such a large population, they exceed the carrying capacity. What eventually happens on the road? Die off. Yeah. It's like you pay the price for having things you need. Okay. So overshoots and die off. Okay?
So overshoot is just
Over, yeah, it's just shooting over the carrying. It was all the overshoot. Yep. Predator prey. Predator prey just shows dynamics between those two organisms. So if we're talking the rabbit population goes up, how's the lynx population going to be affected by a high rabbit population? It's going to go up, right? And then the rabbit population goes down, how's that start to affect the lynx? Yeah, it goes down, right? And that's your predator-prey relationship. It's this relationship where they need each other, right? How does the lynx control the rabbit population? Yeah, it keeps it lower, right? And so that's your predator-prey relationship. So, and you can throw in the here's the carrying capacity. If you exceed it, that's an overshoot, and then we have a die-off. How does the die-off of the rabbits affect the lynx? Well, what happens to the lynx? They exceed their carrying capacity, and now they're running out of food, so same deal. Okay? All right. Good on those? All right. Okay. Size and density of populations. So, as populations get bigger, right, they increase in density. Okay. What are the three types of distribution in nature?
Random. Uniform. Clumps.
Clumps.
Give me a second. I was thinking about my chip.
Okay. So random is random, like seeds from a tree. Helicopters, they just randomly land anywhere. Uniform, they're evenly spaced. That's like territories. Okay, like bears. We did a bear thing, right? Bears have territories. They uniformly distribute themselves. Yep. And then clumps. Why do animals clump?
Because they go with the herd.
Yeah, you're protected, right? Why are zebras all together? It protects them, right? Which is the most common? Clumped. Clumped is most common. Okay. All right, sex ratio is just the ratio of males, females in a population. If the number of males exceeds the female population, then you're not going to have as many offspring, right? And that's the idea. So after World War II, what were the ratios like? What were there more of? There were more females than males in countries like Germany and Russia. Yeah. So, but that's just a sex ratio. That's all I'm talking about. How many males in the population, how many females in the population.
Did you say anything specific about size and density? Just
No, there really isn't. There really isn't anything that big.
so I can work it out?
Well, just understand that as the size increases, so does density. And then when it comes to density, how do they spread themselves out? These three ways. That's all. Okay, limiting factors, that's probably the most important part of the whole section. I mean, that's the whole takeaway. So populations can grow, and then they can be limited in growth by two different factors, dependent and independent. How do you tell the difference between the two?
You tell us.
Dependent factors are living things.
Because they're dependent on.
They depend on each other, right? So biotic meaning, let's say, competition. So if there's a large deer population, aren't they competing with each other? That's a density dependent factor, right? If there's predators, are predators living?
Food resources is that?
Food, that's a dependent factor, okay? Independent factors are abiotic,
Tornado.
and typically they're weather-related things, okay? A drought, a
Would a
tornado.
Would a virus be abiotic or biotic?
Well, I wouldn't throw virus because you can argue that pretty good because you're like, well, viruses aren't living, and, you know, and so, but that's how you tell the difference between a dependent factor and an independent factor. And that's how that all ties into exponential logistic growth. Okay? Got that? That's a big APES thing right there, those two, for this course. So make sure you know independent.
We've got to lock it on
So,
this. Me? We've got to lock it on this.
all right.
Now that I got it wrong, I know.
Age structure. You're going to have some of these on there. Okay? So interpret an age structure diagram. All right. How would I represent a rapidly growing population? Yes. Okay. So let's kind of look at this. But let me draw a better chart. The bottom is broad, which means there's a lot of
Babies.
lots of young people, right? So that means down the road, that population's going to grow really large because those kids are going to grow up, and those kids are going to have kids once they get, I don't know, let's say 16 years old, they have kids or something crazy like that, right? So a broad bottom definitely means rapid growth. How would I show steady growth?
Pillar.
Like 2 long.
Yeah, it's just kind of, it's not perfect, but you know, something like that, that's your steady growth. You know, if you saw the 1995 version of the United States, it's a pillar, but then you gotta account for the baby boomer bulge thing that's in there.
Oh, I do that.
Yeah, and that's kind of our steady growth, you know, baby boomer deal. Now the baby boomers are up
They're
there now.
dying.
Yeah. And then slow growth would be kind of something like that. That thing with demographic transition, and it threw some of you off, it looked like this. Something like that, almost like a spade, but it's showing the bottom part is narrow, meaning they have very few, what's down here? Yeah, very few births. So the bottom's really skinny as opposed to this one, the bottom's really wide. So that's how you want to look at it. Lots of young people, hardly any old people. So this population is probably declining, right? Okay. How many males are female in a particular age cohort? So, all right, if I split this in half and make these into bars, make these red bars, okay? And we'll say these are the females and these are the males, okay? Could you figure out how many males represent a certain age group if you had the chart?
Yeah.
It gave you the numbers, right? So just understand that, you know, this might be, I don't know, I'm just gonna make up numbers, 0 to 5, and this is 6 to 10, and this is 11 to, I don't know, right? And that just shows you in a population what there are of the males and of the females at that particular age. So, okay, and that's what I mean by that, age cohorts, okay? Yeah, and that's what an age cohort is. And then if we do the bulge thing, so we do, what was that country? You guys remember? Qatar?
No, it's in the Middle East.
Yeah, Kuwait is one. I think Qatar is one. Saudi Arabia. Okay. So if over here on the left are males and over here on the right are females, why do we have this weird, you know, males that are 30 to 40 right here?
Coming into work.
They're coming into work. Yeah, I mean, that's it. Yeah, you can look at historical age structure diagrams and then go to the history of that country, and you'll see like huge dips in the male population because so many of the males were killed in whatever war that was. Okay, so that's age structure diagrams. Good on that one? All right. Then the last three sections, more human population stuff. So what does TFR stand for? Total fertility rates. Okay, and just make that into a normal person's lingo. What's that mean?
How many babies you have?
How many babies they're having. Okay. So population growth and total fertility rate. If the fertility rate is high, what kind of age structure diagram would they have?
Triangle.
They'd have a triangle, right? If they have a very high TFR, they're going to have a triangle, meaning they're growing rapidly. Okay. If they're declining, you know, like Italy,
Upside down triangle.
they're going to have the inverted upside down triangle, meaning their fertility rate is, what is that value? What's the number?
2.1.
2.1. If you have a fertility rate of, a replacement fertility rate of 1.4, are you replacing the people that are dying?
No.
No, so your population is decreasing.
Oh, you're only
Okay.
one parent.
In the United States, we're below 2.1, but why aren't we declining? Immigration, yeah. So. Okay, so that's population growth and TFR, replacement level fertility. That's the magic number. Make sure you know 2.1. In more developed countries, what's that number look like? Yeah, it's lower. I mean, doesn't common sense tell you that? It's just like you're more developed, people aren't having kids, right? In a less developed country, it's going to be higher. They're going to be higher than 2.1. Meaning, you know, if we were to pick like Nigeria or something, you're going to be way above 2.1. So. All right, infant mortality rates, meaning
How many babies are dying?
how many babies are dying, okay? So I want to point something out on this one, okay? So an infant, that's children under 1 year old. Okay, that's what an infant is. So that's kind of how we define it. Okay. Child mortality rate. How would you define a child?
Anyone over 13?
5 years
Oh.
of age.
What's a 6-year-old?
They're above that, right? So an infant is anything under 1. A child is up to 5. Okay, so there's child mortality rate and there's infant mortality rate, but that's how we differentiate between IMR and CMR. Okay, so infant mortality rate. Why is it so high in less developed countries?
Not healthcare.
Healthcare. That's the key. Healthcare. You can't get medications. You can't get the shots. Unfortunately, children die from that. Right? In developed countries, they have access to medicine. They're very likely going to survive. Okay. So, now, if we were to go back in time and we were in the 1840s in the United States, why did people have so many kids? A lot of them died because we didn't have medicine. We didn't have that kind of stuff yet. So, yep. But if you're on Oregon Trail, you die of dysentery, right?
Okay, is dysentery diarrhea or constipation?
It's diarrhea. You die of dehydration from going to the bathroom so much. So, yeah, that'd be a bad way to go. Okay, so factors that is causing the decline of infant mortality rate. The number one is healthcare. Okay, that's it. I mean, if you have access to healthcare, you're very unlikely for the child to pass away. Okay. So, what's affluence? That was on your list.
Good and That was a good definition.
Okay,
Birth rate is low and different.
yeah.
Fluent in French, like you're good at French.
Okay. If you're affluent, there's wealth. If there's wealth, what do you have money to do? Yeah, healthcare, education, contraception. You know, all those things are going to happen. So you're an affluent population, so you have a low birth rate. You have a low death rate. Okay, make sense? I mean, it's kind of common sense, right? But you just got to think about it. You're like, oh yeah. Okay, and then like I said, what are factors for total fertility rates? So fertility rates can't, let's say,
Education.
why would they be low? Yeah, education is for specifically who?
Women.
Women. And you saw in that video, if women are educated, they're like, I don't want to have kids. I want to become a doctor first, start my career, then maybe when I'm 28 or so, then I'll have kids, right? Another one is family planning. Okay, they're not just randomly, well, let's just have kids and see what happens. Let's just, you know, they plan it and wait till they're ready financially and everything's in place before they have kids. Yeah. All right. All right. Anything on those? Make sure to make any notes on that. Okay, move on. All right, human population dynamics. All right, factors that are affecting the growth rates. Okay, so what can make a population grow? Just use common sense.
High total fertility rate.
Okay, so birth rate.
High birth rate, low death rate.
Okay, death rate. What's another thing that's gonna make a population grow?
Low mortality.
No, think just simple population growth.
Food, more money.
IMR.
No, immigration
Immigration.
Low immigration.
and
Wait, is this
Total population.
Low immigration.
Whoa.
now we have
Divided by.
no. It's just that birth rate plus immigration, right? Because births and moving in, deaths and moving out, and then after you do that, you subtract. And
We're
that
gonna
will
have that paper of. On
no,
the paper it
you
says
just got to
divided
know
by
them.
total population.
Because in APES they don't give you equation sheets. They just want you to. There's just a small handful of them.
On the paper it says divided by like 1,000 or something.
If we're trying to find rates. Okay, I'll get to that. I'll get to double time. Yeah. Okay, so those are factors that affect growth rate. Yes, and you could talk about the fertility rates and things like that, but that's what I mean on that. Okay. And then I'll get into that more down here. Okay, Malthusian theory. The human population. Now that movie said we're slowing down, but how are we still growing though?
Exponential.
We're still growing exponentially. Don't let that movie fool you. We are slowing, but we're still growing exponentially. Okay? So this is the population, right? The human population. What does food look like? The amount of food.
Linear.
It's linear, right? So population growth is an exponential growth curve, and food, what's that relationship? It's just a linear line, right? And so if we exceed that, that's when we're going to run out of food supply for the people on the planet. But how can technology fix that?
Fertilizer.
Yeah, so fertilizer could be one that would allow us to grow more food, which would do what to this line? Yeah, bring it up. Okay, and we're still figuring stuff out. So technology can fix this. It's not like all hope is lost and we're in trouble. It's just technology as we figure out more things with that. So. Okay, then we get to the math stuff, okay? So remember, these equations, they don't expect you to be a genius for this APES course. They just think, okay, if you want to calculate growth rate, what does common sense tell you?
That's right, Mom.
Yeah, so growth rate is going to be, if it's just basic growth rate, it's birth rate minus death rate, right? And if we want to get like a rate of growth, right? So let's say the birth rate is 8 and the death rate is 2, that equals 6. 6 divided by, what's the number? 10. Right, so 0.6. That's it. That's the rate of growth. Okay? What if it were, and what if this were 20? Then what's going to happen with our rate answer? It's going to be a negative, meaning the population's going down. But that's all rate of growth is. It's just birth rate minus death rate divided by 10. You know, really, it's divided by 1,000 times 100, but why do those extra steps? Just divide by 10. You'll have the answer. Okay. Okay. Growth rate with migration. I already showed you that. What is it? Plus immigration.
Minus death rate plus immigration.
DR plus immigration. There it is. Yeah. Now, what if we wanted to find a rate from that? Divide by 10. Yeah, don't make it hard. Don't make the math hard. This is basic math. So, okay. Okay. So we have growth rate. We have birth rate. What if we just want to know population change? It's just BR minus TR. If that's all you're given in the story problem. Okay. What's doubling time?
7 divided by.
Yeah, that's one you just gotta stick in your head. Okay, 70. Okay, and then divided by the rate. So when I did the 1, we did 8 minus 2 equals 6. 6 divided by 10 is 0.6. So this is 70 divided by 0.6. And that's all you do. And get your answer for how long it would take to double.
What did you say for BR and DR?
BR and DR is just, what if I said, what is the rate of growth given the birth rate and death rate? Right, you would just subtract BR minus DR. So. Okay. All right, any questions on those? Are you okay on the equations?
Birth rate and death rate.
Yeah, and obviously you can use a calculator. I'm not gonna make you not use a calculator. So. Yeah, so you want an example here of this?
Yes, please.
All right. So in a population, there are 40 births in the spring, but 10 of them die. How many animals? What's the I don't want to say rate of growth because then you're going to have to divide. But what if I just said how many are there in the population now? It almost becomes like a 5th grade math problem. So it becomes 40 minus 10 is 30. So.
Well, that's what.
Yeah, but most of the time it's going to be rates. So it's going to be 40 minus 10 over 10. So it's going to be 30 divided by 10. And so what's our rate of growth?
We're not talking about rate of growth, we're talking about birth rate, like, because the birth rate is birth rate, births per 1,000.
Yeah, if you're given the rate,
Divided by 12.
let's say we have a rate of 0.3 and a death rate of 0.2, what is the rate of growth? Well, now you already have it, so it just becomes 0.1.
So this one's
Births over total population times 100. That's
Yeah, so if you had, if we had our rate is 0.3 and there's a population of 10,000, right? So if you gotta do 0.3 times 10,000, right? And so 0.3 times, I don't know why I just did it on a calculator, but oh well. That's our growth rate out of 10,000, so what's our new population size? Is that where you're going?
No.
Okay, well I just invented another
Well, what
problem
you're
for
talking
you.
about isn't even on, like,
It's on.
yeah, but I'm saying.
So let me see which one, let me make sure.
That's just, like, I know how to do it.
Yeah, unless given, unless you gotta figure out based on population size. Yeah. But if it just wants rate of growth, you just divide by 10. So, okay, let's do demographic transition, we'll be done. Okay, so if I were to draw demographic transition, what's it look like?
Oh, it has
That
a
actually
line, it
works.
starts with 2 at the top, it goes down, the other one goes out, down.
Get myself some room here. So, all right, let's do birth rate. You guys tell me what to do. Okay?
They're both high in stage 1.
Yeah, so we'll do birth rate first. And then what happens to birth rate?
Goes down.
Goes down and kind of does that, right?
Yeah.
So this is BR. Now, what's DR do?
It's like,
It drops.
Something like that. Okay?
your drawing's not
Thanks.
there.
All right. So what is this region here?
1.
Stage 1. Okay. Are there any countries in stage 1?
No countries, just tribes.
Yeah, just tribes.
Amazon
Right.
basin tribes.
But there's a high birth rate, a high death rate, and if I did population, the population is
Your
low.
birth rate line is like not right.
Okay, but it gets the point.
Not really.
Okay, so let's do stage 2.
Look at it.
Yeah, okay, I see what you mean now, because I've already do stage 2.
It's already going down.
Yeah, it's already going down. So, yeah,
There you go.
It's okay, you tried.
Yeah.
I,
I knew he could do better, but.
hey, come on. All right, so stage 2, what begins to happen to the death rate?
Death rate drops.
Death rate drops, but the population is still high, right? And then once you get to stage 3, what happens to your population? It begins to decline, right? And your death rate,
Well, it doesn't begin to decline, but it just doesn't change.
right? I mean, India is a massive, it's the largest, most populous country in the world, but they're starting to slow down. So they're now a stage 3, right? Stage 4,
The country's population is actually decreasing.
yeah, so we're gonna make this is a better depiction of stage 4, right? Birth rates and death rates are low. In fact, birth rates are so low, populations are declining, right? Okay. Give me a country that would be a stage 2 country. Nigeria. Ethiopia, right? So rapidly growing countries, lots of high fertility rates. They have lots of kids. You know, in fact, the mentality is I got to have more kids to replace my kids that have died, kind of stuff. Okay. Give me a type of stage 3.
Yeah.
India.
India.
They're like, I don't want to have as many babies.
Right. Give me a stage 4 country. United Kingdom, yeah. Any European country works because they're all declining. They have low birth rates and low death rates. Okay, so you're going to have some random questions about the stages. You know, what's going on.
Is it gonna be like the ones on the thing where it was like about the social security? And
No, it's going to be more obvious. What?
Stage 1 population is low?
Yeah,
Okay. That's all I
yeah. I mean, so many are dying, and then they keep having more kids because they're dying, but their populations aren't really growing. So.
But they still have high birth rate and death.
Yep. Okay, that's it.
You can drink your drink, Prozac.